Hello everyone, this is example 3.5, structural analysis for continuous beam using table 3.5, British Standard 8110. And this topic is under structural design course chapter 3 part 3. The question is, using simplified method, analyze the beam shown below. And this beam is the continuous beam, 4-span beam having 8 meter length at each span. And this continuous beam is subjected to the GK 18.31 kN per meter and QK is 6 kN per meter. We will solve these questions using table 3.5 from British Standard 8110 Part 1, Clause 3.4.3. And this table gives moment and shear forces in continuous beam with uniform loading. Before we proceed further to the equation, first I would like to show you this table. This table is subjected to the following provision. The first one is the characteristic imposed load QK may not exceed characteristic dead load GK. As in our questions, our GK is more than QK. Thus, the first condition is fulfilled. The second condition is the load should be substantially uniformly distributed over 3 or more spans. Let's check. Our span is more than 3. We have 1, 2, 3, 4 spans. And the load applied on this continuous beam is the uniformly distributed load. Condition number 2, check. And this is the third condition. The third condition is the span length should not exceed 50% of the longest. And this is the table. So we have two here. For the first one is the moment and the second one is the shear. And this is the condition of the beam. We have here at outer support, near middle of end span, at first interior support, at middle of interior span, and at interior support. And this is the equation for each condition. The F here is the total design ultimate load, which is for Eurocode, the total design ultimate load is 1.35 GK plus 1.5 QK. Meanwhile, L here is the effective span. And please take note that using this table, no redistribution of the moment calculated from this table should be made. To proceed with the diagram, shear force diagram and also bending moment diagram, first step we need to calculate the total design ultimate load. The total design ultimate load is 1.35 GK plus 1.5 QK, and the answer is 33.72 kN per meter. And to convert this unit to the kilonewton, this value is multiplied with the length of the span of the beam, which is 8 meter, and the answer is 269.75. And this is the shear force diagram. And the answer is already given at each support and span. In this video, I will show you how to read, how to apply this condition from table 3.5 to this diagram. The first one is the shear force diagram. This is the shear force diagram. And we focus to this part, the shear unit in kilonewton. And this is the outer support. Okay, the outer support, the value for outer support is 0.45 multiplied with the F. And this is the outer support for both ends. After the outer support, when we go more further inside, here is the near middle of end span. Same goes to this part. This is the near middle of end span. Thus, the shear for the near middle of end span is equal to 0. When this line crosses this horizontal line and go down, and this point is the near middle of end span. Meanwhile, for this area, go up to this point. This is the near middle, at first interior support. This is the first interior support. This is the first interior support. Thus, 0.6 multiplied with F is at this point. And this is the at interior support. Other than at first interior support, other than this is all interior support if that point is at support. Thus, our interior support is 0.55 F is at this point. And at this area, the mid support here, the mid span here, this is the at middle of interior span. Thus, the value for middle of interior span is 0. Next, let's see the bending moment diagram. Okay, this is bending moment diagram. The bottom figure here, this is the bending moment diagram. So how to read this bending moment diagram using table 3.5 here. This is table 3.5. Okay, so this is the outer support. And this is our reference here. At outer support is equal to 0 for pin and roller support. So moment at the outer support is 0. Then moment at near middle of span. Moment at near middle of span, which is 0.09 FL, is at this point, both sides. This is the outer. When we go further inside, the first span, and this is the near middle of end span. This is the end span, and this is the middle span for the end span. Same goes to this end span. And for at first interior support, negative 0.11 FL, the value is at this point. Next is the at middle of interior span. This is the interior span from support B, C and D, and this is the interior span. Thus, the value for the at middle of interior span 0.07 FL is at this interior span. Next is the interior support. So the interior support is here, 0.08, thus this is the point for 0.08. And finally, we will substitute all of the F value and also L into this equation for each equation, and finally the question is solved. Next, I will show you how to assign formula from table 3.5 to shear force diagram and body moment diagram. This is additional info. This is example number 1. So we have here 3 span, and the first span is 2000 millimeters. Same with the second span. Meanwhile, third span is 2.2 meter. And the load applied on this continuous beam is 1.35 GK plus 1.5 QK. Let's check the condition of this continuous beam if we want to use table 3.5. The first one is the characteristic imposed load QK not exceed characteristic dead load. So if you want to use this table, you need to make sure that the GK is more than QK. The next condition is the load should be substantially uniformly distributed over 3 or more span. So we have here 3 span, and the load is UDL, uniform distributed load. Next is the variation in span length should not exceed 50% of the longest. We have here our longest span is 2.2 meter and the shortest span is 2 meter. So how to calculate these differences? So I'll show you here. This is the equation: 2200 minus 2000 divided by 2000. So the difference is around 9%. Thus, this requirement is fulfilled where the variation in span length is less than 50%. Once all these conditions meet, we can use table 3.5 to analyze this continuous beam. And this is the shear force diagram, the bolt shear force diagram without value. And this is the reference table 3.5. So we will focus on the shear value first, and this is the shear value. Okay, the outer support is 0.45. This is the outer support, 0.45. Meanwhile, for the near middle of end span, the value is 0. This is the near middle of end span. This is the end span, and this is the middle. 0.6F is the at first interior support. So from this top, it goes down here, this point, and this is here is 0.6F. Meanwhile, here is go up, cross this line, horizontal line, cross up here, and 0.6F is here. Next is the at middle of interior span. This is the interior span, and the value is 0. Meanwhile, interior support, so we go from this point, go up, this is the first interior support. Thus, this point is the interior support. Same goes to this point. The 0.55 here at this point and also at this point. So this is the at interior support. Okay, let's check moment. Okay, this is moment. So I will draw the moment diagram. Just imagine that this is the smooth line. Okay. Okay, this is the line. The first one is at outer support. This is other outer support. Is equal to 0. The near middle of end span, this is the end span AB and CD is the end span. Thus, the middle for the near end span 0.09 FL is at this point. Okay, this is the maximum value for the end span. Next is the at first interior support, and this is the first interior support. And then this is the interior span, and the middle of interior span is here. B, this line is divided by 2, so thus 0.07 L is at this point. For this example, there is no interior support. Then we look at example 2. In this example 2, there are 1, 2, 3, 4, 5 span. 6 span. 1, 2, 3, 4, 5, 6 span. And each span length is L. And this load is subjected to the uniform distributed load. And that UDL load you need to convert to the ultimate design load using 1.35 GK plus 1.5 QK. And this is the shear force diagram and table 3.5. First, we check the shear. This is the shear. So for the outer support, this is the outer support, both sides. Next is the middle, near middle of end span. Next is at the first interior support. This is the first interior support. Next, this is the middle of interior span. And finally, this is the at interior support. And this is the shear value at interior support. Next, we check moment. And this is the straight line. I will draw the moment diagram. And again, just imagine this is the smooth line. Okay, this is the bending moment diagram. And our first moment at outer support is equal to 0 at both sides. This is the moment at outer support. Next is the moment at near middle of end span. This is our end span. This is the end span. And 0.09 FL is at this middle of end span. Next is the at first interior support. Negative 0.11 FL is at this point. This is negative 0.11 FL. Meanwhile, at the middle of interior span, this is interior span 1, 2, 3, 4. All this 4 span is interior span, and middle of interior span is L over 2. Thus, our middle of interior span 0.0 L is at this point. At middle of each interior span. Next is the at interior support, and this is our interior span, meaning this is interior support. 0.08 FL negative is at this point, and this is moment at interior support. So this is how we read table 3.5 on shear force diagram and also bending moment diagram. Thank you.